Hello, welcome to Anybody Can Learn. Today we will learn perceptron algorithm. So what is the perceptron algorithm? The perceptron is one of the simplest machine learning algorithms. It is used for binary classification. A binary classification means we have only two possible classes. For example, pass or fail, yes or no, plus 1 or minus 1, disease or no disease. Now understand how the perceptron works. Perceptron look at the input features and calculates a score using weights. Then it learns a decision boundary that separates the two classes. Based on the score, it decides which class the input belongs to. Now recall, what is a feature? A feature is an input variable used by the machine learning algorithm. Let us represent the features as an input vector x. For example, consider the example of student example table. x1 means hour study and x2 means attendance. So these two, x1 and x2, are called as the features, and label means is the correct answer associated with each training example. For example, in this our student example table, y is the class label. For perceptron, we commonly use y is the element of set -1 plus 1. Y is equal to plus 1 means the correct class is positive. For example, pass. Y is equal to -1 means the correct class is negative. For example, fail. Let us take a simple real world example. Suppose we want to decide whether a student will pass or fail. We have two features, x1 is equal to hour studied and x2 means attendance percentage. For simplicity, we write the input vector as x is equal to column vector with element x1 x2. Now let us consider the example of student A. Student A studies for 8 hours and has 90% attendance. Therefore, x1 is equal to 8 and x2 is equal to 90. So we will write the input vector as x is equal to column vector with entry 8 and second entry 90. And if a student A passes, then the true label is y is equal to plus 1. Now understand what is a weight vector. The perceptron assigns a weight to each feature. The weights tells us how strongly each feature contribute to the final decision. The notation for the two features, the weight vector is written as w is equal to column vector with entry w1 and w2. The perceptron calculates the combination w1 multiplied by x1 plus w2 times x2. Let's see the example. Suppose w1 is equal to 2 and w2 is equal to 3, then weight vector is written as w is equal to column vector with first entry 2 and second entry 3. Now understand the basic prediction formula. The perceptron calculates a score z using the formula z is equal to w transpose times x plus b, where z is the score and w is a weight vector, x is the input vector and b is bias. We use y hat, that means a predicted value. and the prediction rule is very simple. Y hat is equal to plus 1 when z is greater than or equal to 0, and y hat is equal to minus 1 when z is less than 0. That means if this W transpose X plus B is greater than or equal to 0, we will predict the value as plus 1, and if this W transpose X plus B is less than 0, we will predict the value as minus 1. Note that Y hat means prediction and Y is the true label from the data. Now understand the decision boundary. The perceptron predict plus 1 when W transpose X plus B is greater than or equal to 0. So perceptron will predict it as plus 1, and when W transpose X plus B is less than 0, then perceptron will predict it as minus 1. The exact boundary between these two classes occurs when the W transpose X plus B is exactly equal to 0. For two features, this forms the equation W1x1 plus W2x2 plus B is equal to 0. Because this is a linear equation, it creates a straight line. Therefore, the perceptron is called as a linear binary classification. For two features, it forms a straight line. For three features, it forms a plane, and for higher dimension, it forms hyperplane. Now understand how does the perceptron learn. So far we know that how to make a prediction. Now comes the important part, learning the weights. We normally start with the 0 value for everything. That means we start with W is equal to 0 and bias B is equal to 0. That means our weight vectors is 0 and our bias is 0. For two features, we starting the weight vector is W is equal to column vector with first entry 0 and second entry 0. And the learning process is the perceptron examines training example one by one, and if it predicts correctly, it does not need to change its weights, but if it makes mistakes, then perceptron must update the weights as well as bias. And the update formula for weight is Y times W transpose X plus B is less than or equal to 0, then the perceptron will update the weight, and the update formula for weight is W is replaced by W plus Yx. That means W new is equal to W old plus Yx, where Y is a true level and X is the input vector, and this W means old weight. The bias is updated by the formula B new, that is bias new, is equal to bias old plus Y. That means replace B by B plus Y, where Y is the true level. Now let us do a complete example to understand perceptron in more detail. We have a small data set with two features x1 and x2, and we will start with the initial weight W is equal to column vector with the first entry 0 and second entry 0, and bias B is equal to 0, and the training data given to us is example 1 have x1 2 and x2 1 and its true label is plus 1. For example 2, the first feature x1 is 1 and second feature x2 is 2 and its true label y is -1. For example 3, the first feature x1 is 3 and second feature x2 is 1 and its true label y is equal to +1. And for fourth example, for first feature x1 is 1, second feature x2 is 3 and its true label y is equal to -1. We will process this training example one by one to see how the perceptron learns. Now consider the first example, that means example 1 with feature 2 1 and label +1. So the input vector is x is a column vector with entry 2 and second entry 1 and its true label is given as +1, and we initialize the weight with a column vector 0 and 0 and bias as a 0. So let's calculate the score. Score is calculated by the formula z is equal to w transpose x plus b. So w transpose means its row vector with the first entry 0 and second entry 0, and it is multiplied with the feature vector x. So 0 multiplied by 2 plus 0 multiplied by 1 plus 0 means bias plus 0. So our z is a 0. We know the prediction rule. If w transpose x plus b is greater or equal to 0, then we will predict +1. So here our z, that is w transpose x plus b, is 0, that means it is equal to 0. So we will predict the y hat is equal to +1. Our true label given in our example is +1, so our prediction is correct, so no update is required. So our weight remains same as it is, that is w is a column vector with entry 0 and second entry 0 and bias as 0. Now see the second example, which has a feature 1 2 and its true class is -1. Current state of w is a column vector with a 0 and 0 and bias as a 0. So we will calculate the score with the formula z is equal to w transpose x plus b. So w transpose is 0 0 and x is a column vector 1 2. So 0 multiplied by 1 plus 0 multiplied by 2 plus 0 means b. So our z is 0. We know the prediction rule. If the w transpose x plus b, that is z, is greater than or equal to 0, we will predict y hat as a +1. That means we will predict the class as a +1. So our prediction is y hat is equal to +1 because in this example z is 0. But the true label given in our example is -1. So the perceptron has made a mistake. As the perceptron made a mistake, we need to update the weights and bias. The weight is updated by the formula w new is equal to w old plus yx. Our w old is a column vector with entry 0 0 and y is a given, that is a true label given to us is a -1 and x is our feature vector, that is column vector 1 2. So our w new is -1 and -2, that is column vector with a first entry -1 and second entry -2. Similarly, we will update the bias. The bias is updated by the formula b new is equal to b old plus y. Our b old is 0 and our y, that is true label given to us, is -1. So 0 plus -1 is equal to -1. So our new bias is -1. Thus the new state is w is a column vector with entry -1 plus 2 and bias is -1. Now see the another example, that is example number 3. The example number 3 has a two features 3 and 1 and its true label y is +1. So our x is a column vector with entry 3 and 1 and true label y given to us is +1. So current state of the w is column vector with entry -1, -2 and bias is -1. So we will calculate the score. Score is calculated by the formula W transpose X plus B. So W transpose means row vector -1, -2 and X is a feature vector 3, 1. So -1 multiplied by 3 plus -2 multiplied by 1 plus B. B because our bias is -1, so it's -1. That means -3, -2, -1, that is equal to Z is equal to -6. By the prediction rule, we know that if the Z is less than or is greater than or equal to 0, we will predict it as +1, and if Z is less than or less than 0, we will predict the class as -1. Here our Z is -6, that means our Z is less than 0, so we will predict y hat is equal to -1. But the true label given to us is +1. Here true label for the example 3 is given to +1. Therefore we made a mistake. That means prediction perceptron make a mistake. As the perceptron make a mistake, we need to update the W and bias. So W is updated by the formula W is equal to W plus Yx. That means W new is equal to W old plus Yx. Our W old is column vector with entry -1 and -2. Y given to us is that is a true label is +1, and X is a feature vector with entry 3, 1. So it is column vector -1, -2 plus column vector 3 and 1. So -1 plus 3 is 2 and -2 plus 1 is -1. So our W new is a column vector with entry 2 and -1. Similarly, we will calculate or update the new bias by the formula B new is equal to B old plus Y. Our B old is -1 and our true label Y is 1. So -1 plus 1 is 0. So our B new bias new is 0. Now check the fourth example. The fourth example has a feature 1 and 3 and its true label Y is -1. So our feature vector for example 4 is column vector with entry 1 and 3 and Y is -1. The current state of the W is column vector with entry 2, -1 and its bias is 0. So W transpose means its row vector with entry 2 and -1. Now we will calculate the Z by the formula W transpose X plus B. So it is a row vector 2 -1 multiplied by column vector 1 3, that is our X, and plus B. B is 0. So 2 into 1 plus -1 into 3. So it is a 2 minus 3, that is Z is equal to -1. By the prediction rule, we know that if Z is less than 0, we will predict the Y hat, that is a class, as -1. Here Z is -1, that means Z is less than 0. So we will predict the Y hat is equal to -1. The true label is Y is equal to -1 given to us. That means our prediction is correct. As the prediction is correct, no update is needed. So the final weight for this pass is W is equal to column vector 2 -1 and B bias is 0. Now what did the perceptron do? Let us summarize the entire learning process. First example, the true label given to us is +1 and perceptron predict is as a +1, so no mistake happens, therefore no update required. For second example, the true label given to us is -1 and perceptron predicted it as a +1, so mistake occur. Therefore the update needed both for weight and bias. For third example, the true label given to us is +1 and perceptron predict is -1, that is means the mistake happens, so we need to update the weight and bias. For fourth example, true label given to us is -1 and perceptron predict it as -1, so no mistake occur, so no update needed. The next step is, this is essentially the perceptron algorithm in action. We continue through all the training examples. We repeat the process for additional passes or epochs until the training data is completely correctly classified or a chosen maximum number of iteration is reached. Thank you.